Hello everyone. In this video, we're going to take a look at climbing stairs problem. Difficulty level is easy on this problem. So we're given n stairs. So everybody knows staircases, right? So we're given 5 staircase or 10 staircase, and then at a time we can climb only 1 step or 2 step. And by doing that, we need to say that in how many distinct ways we can reach to that nth staircase. So if we take our example 3, so we're given there are 3 staircases. So what we can do is we can take 1 step at a time and then we can go to third stair. So that's one way, right? One, one, one. What other way we can do is we can take 1 step and then we can jump 2 steps. So we reach third step. So that's another way. Or what we can do is we can jump to the second step, we can take 2 steps, and then we can take the third one final step. So there are 3 distinct ways we can reach to third step if we are allowed to take 1 step or 2 step at a time. So that's our problem and that's our example. So for 4 staircases, we can do that in 5 ways. We can see that in detail in whiteboard. So what we'll do is we'll go to the whiteboard, we'll figure out the approach, and then we'll come back and run the code to confirm our approach. So let's do that.
So let's look at climbing stairs problem. We'll assume that we have 4 staircases, so our n is 4, and we can take either 1 step or we can take 2 steps. So let's first of all manually try to do it manually and see what we get. So let's say if we have to go to staircase 1, how many ways can we do it? We just take 1 step and we are there. So we can do it in one way, right? Simple. Now, if we have 2 staircases, then what we can do? We can take 1 step, that's one way, or we can simply go to 2 step. That's second way, right? So 1, 1 and 2, that's our 2 ways, right? So still so far simple enough, right? Now let's move on to third staircase. So what we do over here is first of all straightforward 1 step at a time, right? So 1 step, 1 step, 1 step, that's one way, right? Next what we do, we jump to 2 step and then we take 1 step, that's second way, right? Or third way what we can do is we can take 1 step and then we can jump 2 steps, right? That's our third way. So we have total 3 ways, 1 1 1 2 1 1 2. So that's our 3 ways to reach to third staircase, right? Now let's do for the fourth staircase. So as you guys can see, I've written it out, right? 1 1 1 1 2 1 1 1 2 1 1 1 2 and final 2 2, 5 ways. So in order to reach to fourth staircase, we have 5 different ways. So now we've figured out some basic numbers, right? Basic staircase exercises. So now if you notice carefully, we might find some pattern, right? So first of all, let's start from here, right? So we have, for to reach to third staircase, we have 3 ways. So if you notice, obviously 2 plus 1 is 3, and if we want to go here 5 ways, 3 plus 2 is 5. So we're getting some pattern, right? We just have to add previous 2 steps. So let's make sure that that's a correct finding, right? So what we do is when we are at step 3, what we say, okay, I'm at step 3, I want to reach to step 3, sorry. So when we are at step 2, the only way to reach to step 3 is by taking 1 step, right? You're at step 2, the only way you can reach is take 1 step and you're at step 3. So what we do is we take these solution sets at step 2 and we just add 1 to it, right? So 1 comma 1 and 1. So that's 1 comma 1 1 2, right? So 2 comma 1 2 comma 1. So these are 2 valid ways to reach to step 3. And now if you are at step 1, how do you reach to step 3? You can simply take 2 steps from here, right? You've already done the 1 step thing, right? So the only way left is 2 step thing. So from 1 you can jump to 3 by taking 2 steps. So what we do, we take this one and we put 2 behind it. So 1 comma 2, that's one more unique way to go to step 3, right? So that makes sense. We can do it in 3 ways and we can derive those 3s from the previous 2 ways. Let's make sure that that pattern confirms to the next step also. So let's go to the fourth step, right? So let's apply the same logic. We are at third step, right? we can take one step and we reach to 4. So let's take all 3 and put 1 behind it. So 1 1 1 1, that's our first one. 2 1 2 1 1, second way. 1 2 1 2 1, that's third way. Guys, it's happening. Now let's say we are at second step, right? So we can take 2 step and we reach to the fourth step. So we take these 2 and we put 2 behind it. So 1 1 2 1 1 2 2 comma 2. So we're getting there. So we can do it in 5 ways. So our pattern is correct. We are able to find out a formula to do that. So what we are doing is, in order to reach to nth step, we need to only consider the previous 2 steps. We just add those 2 ways and then we have our result. So let's see how we'll do that. So we boil down to this formula, right? So ways of 3 is equal to ways of 2 plus ways of 1. Likewise, ways of 4 is equal to ways of 3 plus ways of 2. So if we have to generalize this formula, it'll look like if we have to find out ways of n, then it'll be ways of n minus 1 plus ways of n minus 2. So if we simply write a recursive function, it'll look like this, right? Ways of integer n, if n is less than equal to 0, then return 0. If n is equal to 0 or 1, return 1, or else return of ways of n minus 1 plus ways of n minus 2. So let's see how this recursive function will work. So if we call this recursive function for n equal to 4, then we would get these kind of calls. We'll get way of 4, which will spawn 2 calls, right? N minus 1 and n minus 2. So way of 2 and way of 3. Now way of 2 will again spawn 2 calls, right? Way of 1 and way of 0. And way of 3 will again spawn 2 calls, way of 2 and way of 1. And way of 2 will again spawn 2 calls, way of 1, way of 0. We are not going into negative calls, so for simplicity. So now we know that this will return 1 1, so this will come back with 2. This will return 1 1 2 1, so this will come back with 3. So our total would be 5 ways, right? So we're getting our output, we're getting what we need. However, if we notice, there is slight repetitiveness. So we're calling way of 2 couple of times, we're calling way of 1, way of 0 couple of times. So we're repetitively processing something which we already know. So like if we calculate way of 2 over here, we don't need to do it again. So let's try to optimize this algorithm. Let's try to use bottom-up or dynamic programming approach. Okay, so this is our bottom-up approach or dynamic programming approach. So what we do in this is we declare a array dp dynamic programming for n plus 1 spaces, and we initialize dp of 0 is equal to 1 and dp of 1 is equal to 1. And then what we do, we run loop for 2 to n, and then we apply our formula, which is dp of I is equal to I minus 1 step, dp of I minus 1 step plus dp of I minus 2, and then we simply return dp of n. So let's run this algorithm. Let's see if it gives us our ways of climbing stairs. So let's apply over here, right? dp of 0 is 1 and dp of 1 is 1. So when we run the loop, dp of 2 would be dp of 1, which is 2 minus 1, 1, and 2 minus 2, 0. So dp of 1 plus dp of 0, which is 1 plus 1, 2. And when we come to 3, so dp of 3 would be dp of 3 minus 1, which is 2, dp of 3 minus 2, which is 1, so dp of 2 and 1, which is 3. And likewise, if we keep doing that, we'll keep getting our output, right? 5 plus 3, 8, 8 plus 5, 13, and you guys can keep doing and you'll get the expected ways of climbing stairs. So that's our bottom approach and dynamic programming. So the time complexity for this one is O of n, and there is a space complexity to it. Since we are using dynamic programming or DP array, there is a space complexity of O of n. So what I want to mention over here is, if you notice this sequence, it almost looks like a Fibonacci series, right? So in Fibonacci series, we have starting with 0, 1, and instead of that we are starting with 1 and 2. So just like starting difference, but otherwise it looks like complete Fibonacci series. So we can implement that algorithm where we can get rid of the space requirement. We can just simply add previous two numbers and we don't need this complete whole array. So we can I can show the Fibonacci code when we go to the computer, and when we run the code we can look at. So however, I want to generalize this approach. So in this example what we did was, we are given that either we can take step 1 or we can take step 2. Let's say in some other scenarios we are told like, okay, by the way, you can take either step 1 or step 3 or step 5. Then what will you do? So that's why let's take this approach and generalize it. So let's say if you are given this, right, 1 3 5, then our formula will look like this, right? Ways of n is equal to ways of n minus 1 plus ways of n minus 3 plus ways of n minus 5, right? Based on this we can derive this, right? And if we just have to rewrite this code, we just change this calculation and we replace it with dp of I is equal to dp of I minus 1 plus dp of I minus 3 plus dp of I minus 5. So simple, straightforward enough, and we get this problem solved. So what we can further take this is, what we'll do is, let's say we do it for any case, right? You're given that, okay, you can take step 2 and step 4. Okay, you can take step 1 and 3 at a time, or you can take step 1 and 4. How will you do it? So not difficult, pretty simple. All we do is we change this formula and we apply some generalization to it. So let's see how we'll do it. So what we do is, rest of the things remain same, our outer loop remains same. Only thing is, let's say we have this array, right? We have this steps array which will define whether we have 1 3 5, 1 4, 1 3, whatever. And what we do is we have inner loop where for j is steps, right? J is each step, and we do, if I of I minus j is greater than equal to 0, then count plus equal to dp of I minus j. And once this loop finish, we say dp of I is equal to count. So what we are doing, so let's say our steps is 1 3 5, right? So over here j will be 1, and let's say our I is 2. So, or for simplicity, let's say our I is 5. Okay, so our I is 5. So we are doing j is steps, so j will be 1. So we do 5 minus 1, 4. So count, we add dp of 4. Okay, now our j is 3. So 5 minus 3, 2. So we'll do count plus dp of 2. Now our j is 5. 5 minus 5, 0. So we'll do count plus dp of 0. So if you notice, what we did was dp of 4 plus dp of 2 plus dp of 0, and we added it to dp of 5 is equal to, so n minus 1, 5 minus 1, 4, 5 minus 3, 2, 5 minus 5, 0. So we are almost doing this, but we are doing generalization. So there you go, guys. This is the generic form of this problem. So if you guys want to go ahead and implement the generic approach, I would highly recommend it, so that if you are asked some other steps thing, then you can simply use this and then solve your problem. So let's go to the computer, let's see these approaches, let's run the code and make sure that we get our output.
Okay guys, this is our final code for climbing stairs problem. Okay, so as promised, I'll show you the Fibonacci way of doing it. So this is Fibonacci way of doing it. We have n minus 2 equal to 1, n minus 1 equal to 2, and total equal to 0. We declare three variables, and then we simply run the loop, and we do n minus 2 plus n minus 1. So previous two steps. So that's our total. And then if we have to iterate further, what we do is we take the previous step to the next step, right? So n minus 2 becomes n minus 1, n minus 1 becomes total, and then in next iteration, we add those two numbers again. And we keep doing that until we reach our nth step, and then we return the total. So that's simple way of doing it. And now let's look at the generic way of doing it, right? So again, it's similar to what we discussed on the whiteboard. We have so first of all, we have a dynamic programming array, and then we have outer loop of 1 to n, and then we have inner loop of steps. So whatever steps are there in array, it doesn't matter whether it's 1 2, whether it's 1 3 5, 1 4, it'll handle all the cases. So we simply check if it's so our current value, current staircase minus step is greater than 0. If yes, then keep adding that and then add it in the DP array and then simply return the DP of n. So I have my main method where I'm calling the Fibonacci way of it and generic way of it. So let's run it. Let's make sure that they both return the same values and correct values. So there you go. 3 stairs 3 ways, 4 stairs 5 ways, 5 stair 8 ways, and likewise. Now I'm calling this for uh, my array. Let's go to the right. Yeah. So I'm calling it for 1 and step 2, right? So let's try to change this. Let's run it for 1, 3, and 5, or let's make it 1 and 4, right? Let's see if the values change. So let's run it. Okay, I didn't save it. Okay, let's run now. Sorry about that. Yeah, there you go. So since we are doing like 1 stairs and 4 stairs, you can go to 3 stairs in only one way, right? You can go to 4 stairs in 2 ways. So you can do 1 1 1 1, or you can simply jump 4 stairs. So there you guys, our generic logic is working. So we can do any number of steps and our code will work. So there you go, guys. That's it for this problem. If you guys liked how from problem statement we came to the solution, then give me a big thumbs up. And as usual, hit the subscribe button, press the bell icon for more videos, and see you in next one.